So let's start with question 1. Find the area of a rectangle with a length of 12 feet and a width of 8 feet. So what are they asking for? They want you to find the area. Now you're not going to be able to highlight and use colored pens when you take the exam. You will have scratch paper, you will have a pencil, and you will have a basic calculator. You don't need a scientific calculator. I purchased this one for myself. It's gone through several certification exams with me. I use this and I don't use anything else because I'm very comfortable with this calculator. In Arizona, they allow us to take the calculator in as long as it's not scientific. And so I'm very comfortable with that calculator. And I've used it in several exams. So the first approach, find the area. Now, find the area of a rectangle with the length and the width. Let's go to our math formula sheet. And right here on the first page, area of a rectangle equals length times width. Now you'll see there's no units of measure there. There's no units of measure that says the length is in inches or feet or some other unit of measure. So let's write down this math formula sheet. This equation from the math formula sheet. Area equals length multiplied by width. That's simple, that's straightforward enough. Now the units of measure in this question are in feet. When it asks for area of a rectangle, it's looking for the square footage. Area equals square footage. Like say the area of a room. If you're in a room, if the office at your plant is 12 feet by 10 feet, you would multiply 12 times 10, it would give you 120 square feet. We can write it as square feet. This also means square feet. This is the length. This is the width. So let's take this question and let's take what we know. We are looking for the area, and in this case, because we have the units of measure in feet, we're going to need to determine what the area is in square feet. This is the way you're going to see me write this. We're going to multiply that by the length, which is 12 feet. The length is multiplied by the width, which is 8 feet. So now we have 12 feet and 8 feet. 1, 2 foot squared. So just by looking at this equation, it looks like if I multiply 12 feet times 8 feet, I'm going to get the area in square footage. 1, 2, here's 2. Let's try it out. 12 feet times 8 feet equals 96 square feet. Now we want to look for the most correct answer. We're going to have 4 choices, sometimes 5. And you know, most of the time you can eliminate 2 right off the bat. But let's see what we have here. 96 square feet. Well, I can see this unit of measure is in cubic feet. I'm going to eliminate that. This one's also in cubic feet. I'll eliminate that. Now we're down to 96 square feet. Well, look at A. The correct answer is A. Now we get to fly through these. Question number 2. Calculate the area of a rectangle with a length of 23.5 feet and a width of 10.75 feet. It wants the area. Calculate the area. That's what we're looking for. So the first thing I can do is write down area. And we know it's a rectangle because it has a length and a width. Again, we go to our ABC math formula sheet. Area of a rectangle, length times width. Area equals length multiplied by the width. Now we have our formula. Now we need the units of measure. The units of measure are in feet and feet. It says calculate the area. It doesn't say calculate it in square inches or square feet or some other unit of measure. So even by looking at the choices, I can see that it's in feet. So I need to rewrite this formula. Whoops. Area in feet squared equals, let's see if I can get this down. Length. The length is 23.5 feet. We're going to multiply that by the width, which is 10.75 feet. All right. We have one unit of measure of feet here, a second one here, 1, 2. That makes our unit of measure square feet. If I multiply this by this, I will get this. Let's try that out. 23.5 feet times 10.75 equals 252.625 square feet. Well, let's look at my choices. Right away, I can eliminate 2 of them. They're both in cubic feet. I take off C and D. That leaves me with A and B, which are in square feet. 252.625. The most correct answer is 252 square feet. The answer is A. Question number 3. A primary clarifier is 22 feet wide and 38 feet in length. What is the area of the clarifier in square feet? Well, I'm going to go ahead and highlight that whole part of the question because it wants the area of the clarifier in square feet. That makes it very simple. So I want the ABC formula of area equals length multiplied by width. I know this is the correct formula because this is a primary clarifier, but it's got a width and it's got a length. That's going to be my formula. Now, the units of measure are in feet. I can see by the question it's in feet. And right here where I highlighted, it's asking for the square footage. So area in square feet equals the length (38 feet in length) multiplied by the width, (22 feet). Let's see if my formula makes sense. I want the area in square feet. The length is in feet. There's 1 foot. There's 2 feet. Checks out. Square footage. Let's multiply it out. 38 feet times 22 feet equals 836 square feet. Let's look at our choices. Right away I can eliminate 2 of them because they are in cubic feet. I have 836. Here it is, just as we calculated. The answer is B. Question number 4. Calculate the area of a circle with a diameter of 12 feet. It's asking for the area of a circle. Well, now we've got a new challenge here. Instead of a rectangle, now we're going to a circle. It's a different shape. On my ABC math formula sheet, we have area of a circle, 0.75 times the diameter twice. Now you could calculate this using this formula. Area of a circle equals the radius, equals pi multiplied by the radius twice. In these situations where we have 2 different methods, 2 different conversion factors to use to make a calculation, and this is based on advice from a close friend of mine that helped me understand the math. He tutored me early in my career, and he explained that it's good to pick one, use that every time. You're familiar with it, you understand it forward and backwards. Makes a lot of sense. So in this video series, I am going to use the 0.785 conversion factor whenever it comes to a circle or a column. And I'll go into that more later. So now we have a circle. We're going to use the formula from the ABC math formula sheet of area equals 0.785 multiplied by the diameter and in the formula sheet you'll see it says diameter with the squared symbol. I write it out, which is exactly the same thing. Diameter again, so it's 0.785 times the diameter times the diameter. Excuse my penmanship. So now we have to take that formula and add the units of measure. The area is going to be not in inches, it's going to be in feet. Equals 0.785. That's our factor. That's our conversion factor. It doesn't get a unit of measure in this case. The diameter. The diameter of this circle is 12 feet. So we'll write it down here. Diameter 12 feet. We have to multiply it again by the diameter. Oh, just made a mistake. Diameter, 12 feet. All right. Let's look at our units of measure. I've got foot here, foot here. This conversion factor has no unit of measure. We got 1, 2. The area is going to be in square footage. Let's go ahead and calculate that out. 0.785 times 12 feet times 12 feet equals 113.04 square feet. Let's look at our choices here. We have one of them that's in cubic feet. We're going to get rid of that. Now we're left with, looks like the most correct answer is C, 113 square feet. And this is very common in certification exams to come up with an exact number, which is not one of the choices. You have to pick the most correct answer, which also means you have to know how to round. All right. Let's go to the next question. Question number 5. Find the area of a circle with a diameter of 10 feet. We want the area of a circle. The math formula we're going to use is area equals 0.785 multiplied by the diameter, and then we'll multiply it by the diameter again. This is the formula. Let's add in the units of measure. We'll rewrite it to add in these units of measure again. We're looking for feet. The answers, the possible answers are all in feet. So let's write this again with the units of measure. Area is always in square footage. Use the conversion factor of 0.785. Now I write this, anytime you have a decimal point and there's no numerical value to the left of the decimal point, I put in that 0, the decimal, and then in this case 785. I instruct my operators to do this, my students in my program. As operators, we want to be very precise and legible when we make recordings by hand in our records, in our logbooks, in our bench sheets. And if you write that 0 with the decimal, it's difficult to miss that decimal. If you write just 0.785, some people might not see the decimal point. And that's not their fault. We just want to eliminate any confusion. 0.785 times the diameter. And the diameter in this case is 10 feet. We're going to multiply it by the diameter again of 10 feet. Let's see if the equation makes sense. 0.785, there's no unit of measure. We have 10 feet here, 10 feet here, 1, 2, matches out. So let's solve this thing. 785 times 10 feet times 10 feet. That equals 78.5 square feet. Let's look at our choices. Well, here we go again. We're looking for square footage. Let's eliminate B. 78.5 square feet. Here's our answer. D. The correct answer to question number 5 is D. Question number 6. Find the area of a circular clarifier with a diameter of 7.25 feet. Find the area. That's what the question wants us to do. The ABC math formula sheet, you'll find area equals the length area, and see, I make mistakes. Area equals 0.785 multiplied by the diameter. This is circular, not rectangular. Multiplied by the diameter again. All right, let's add our units of measure. We can see that the diameter of this clarifier is in feet. Our possible answers are all in feet. So we want area, which is represented in this case in square feet. Our conversion factor 0.785. We'll multiply that by the diameter, which is 7.25 feet. We'll multiply that by the diameter again. .25 feet. Now we're going to check. We're going to check our equation. We're looking for square footage. There's no unit of measure here. We have feet, one of them, two of them. That gives us square footage. Let's multiply that out to solve. 0.785 multiplied by 7.25 times 7.25. That equals 41.26, 15625. We're just going to leave it like this. It's going to be square feet. Let's see what our choices are. This is area. We want square footage. We can eliminate B, which is in cubic feet, and also C in cubic feet. That leaves us with two choices. 41.26. The closest and best answer is D. Let's go to question number 7. A primary clarifier has a length of 12 feet, a width of 8 feet, with a depth of 15 feet. What is the volume in cubic feet? It wants the volume in cubic feet. Cubic feet, this is three-dimensional. It's a three-dimensional space. We have a length, a width, and a depth. First of all, let's talk about height versus depth. Height is typically from ground level or grade to the top. If it's a wall it would be the bottom of the wall to the top of the wall. Okay, so height is from bottom to top. Depth usually means something else. It usually means that we have a basin or a tank or a reservoir. They're all interchangeable terms. That's filled with a liquid substance. It could be water, it could be chemical. So the depth of that basin, or excuse me, the depth of the water in the basin is the liquid substance is going to be very rarely at the rim. We don't want to operate that way. We don't want a chance that we're going to spill. So this would be bottom to, in this case, we'll just call it water level. Water meaning it could be a chemical, anything liquid. Okay? So let's talk about a primary clarifier that has a length, a width, and a depth. This is a rectangular structure. And if we draw it in 3D, it will look something like this. And inside this basin, tank, reservoir, clarifier is where the liquid is held. It will have a length, it will have a width, it will have a height, and in some cases, a depth. Our math formula sheet, let's go to, again, we're looking for volume in cubic feet. Let's find volume. Look at that, went right to it, like I've done this 100 times. Volume of a rectangular tank equals the length times the width times the height. So let's write that down. Volume equals length times the width times the height, and in some cases depth, that's probably more correct. In this question, it calls it depth. We're not going to be too worried about that right now. Now let's add our units of measure. Our units of measure are in feet. The width is in feet. The depth is in feet. So our volume is going to be in cubic feet. Remember, cubic feet is volume. That was my work phone. Yep, I get calls on weekends. Just so you know, I'm in charge of all field operations for this utility. I don't think I'm supposed to say the name of the utility, so I'll keep that a secret for now. But field operations essentially is distribution, everything from the well sites to the customer. And then from the customer to the wastewater plants, we have the collection system, which includes lift stations. And depending on how you look at it, fortunately or unfortunately, I have 33 lift stations, soon to be 34, a couple more in the works. It's a very large system, takes a lot of work, and I love it. I have a passion for it. So I don't mind the phone calls, even on the weekends, just to ensure that our infrastructure is in good working condition. So where were we? Question 7. Units of measure. The volume in cubic feet equals the length and the length here is length of 12 feet. 12 feet. We have a height. Oh, excuse me, the width. Didn't sound right even when I said it. Length times width. And in this case, the width is 8 feet. Now we have height or depth. In this case, we have a depth of 15 feet. Let's check our units of measure. We're looking for cubic feet. Here we have feet, another one, and a third one. 1, 2, 3. That checks out. So let's do the math. If we multiply these three together, we should get the volume in cubic feet. So we have 12 feet times 8 feet times 15 feet equals 1,440 cubic feet. Let's look at our choices. Right away, I see that this is in square feet. I'm going to eliminate this one. F is also in square feet. I'll eliminate that one. We're left with cubic feet, and in this case, 1,440 cubic feet is H. The solution to question 7 is H. Let's go to question 8. Question number 8. Find the volume of a rectangular tank with a height of 23 feet, width of 15 feet, and a length of 115 feet. So it wants the volume. Find the volume. Well, we've looked at our ABC math formula sheet, and we know that volume is equal to length multiplied by the width multiplied by the height, because it's a rectangular tank. So let's convert that formula by filling in our factors. Let's fill in these units of measure and rewrite the formula. We're looking for volume. That will be in cubic feet because we have our units of measure are all in feet. Our possible answers are all in cubic feet. So we'll enter the length. The length is 115 feet. This is quite a tank. The width is 15 feet. And then we have a height of 23 feet. Let's check our equation to see if it makes sense. We are looking for cubic feet. We have 1, 2, 3. 3 units of measure all in feet. That adds up to cubic feet. Let's calculate it out. 115 multiplied by 15 multiplied by the height, 23 feet. That's going to give us 39,675. Let's make that look like a 6. And this is cubic feet. 1, 2, 3. There's 3. Matches up. Let's check our choices here. Well, right away I see C and D are in square footage. I can eliminate those. That gives me these two choices. The closest, most correct answer is A. Question number 9. Calculate the volume of a rectangular tank with a length of 75 feet, a width of 55 feet, and a depth of 21.5 feet. So we want to calculate the volume. That's what the question is asking us to do. That's the challenge. Our ABC math formula sheet tells us the area. I'm not looking for area. I'm looking for volume equals length multiplied by width. And in this question, we're looking for depth. So let's add in our unit of measure. So we'll rewrite the formula. Volume, it's volume, so it'll be in cubic feet. It's 3-dimensional. We have our length. Our length is 75 feet. Our width is 55 feet. And our depth (21.5 feet). Now let's check. Let's check to see if our formula makes sense. We're looking for cubic feet. We have 1, 2, 3. That seems to match up. Let's make our calculations. 75 feet times 55 feet times 21.5 feet equals 88,687.5 cubic feet. Well, right away I look at A and B. Those two choices are in square feet. I'm going to eliminate those. We have cubic feet, and look how close they are together. 88,700 cubic feet, 88,600 cubic feet. Well, now we've got a round. If it was 88,499 cubic feet, I would round down to 88,000 cubic feet. At 88,500 cubic feet, you round up. You see the difference here is 88,000. It's that 499 versus 500 or 500. 500 and over, from 500 to 599, you round up. From 400, from 400 to 499, you round down. So you could round this up to the next highest value. We could just simply call it 89,000 cubic feet. In this case, we're going to take 88,687.5, 687.5, and because it's over that 5, we're going to round it up to 88,700. The correct choice is C. Question number 10. Calculate the volume in cubic feet of an 18-foot deep clarifier with a diameter of 12 feet. Well, first of all, let's talk about circles, columns, anything with a diameter. So we want the volume in cubic feet. This is a three-dimensional object that is circular. We know it's circular because it says diameter. So let's draw this. We have something that's circular. It has depth. So it's a round tank, a round reservoir, a round clarifier. The diameter goes from one edge to the other. The depth goes from floor to the top of the water level. So this tank might only have a water level that doesn't quite reach the top. Anytime you're dealing with circles, with a round structure, keep in mind that you have a circle, and if you go to the very center and draw a line to the furthest edge, which could be anywhere in this circle if it's a perfect circle, this is the radius. If you go from one edge through the middle all the way to the furthest edge, we call this the diameter. And because we are going to use the formula for diameter, in fact, let's pull this one out. We're looking for volume of a cylinder. So this structure with a diameter of 12 feet, it's a large cylinder. Now this might be a stick of pipe. You might have a 4-inch diameter pipe that's 10 feet long. This is also a cylinder. We'll keep that in mind for later on in the series. So, math formula sheet. Volume of a cylinder equals 0.785 times the diameter times the diameter times the height. So let's write that down. Our ABC math formula is volume equals 0.785 multiplied by the diameter multiplied by the diameter, and in this case we have depth So let's rewrite this equation with the units of measure. We're looking at feet. So we're going to write in the feet. Volume in cubic feet equals 0.785 multiplied by the diameter. The diameter is 12 feet. We'll multiply it by the diameter again. And yes, whenever I take a certification exam, which thankfully I'm done, I've taken all of mine, all 16 of them, I always approach each problem writing it out completely. I go step by step, the same way I'm showing you. This is how I do it every time, because by the time you're done with this series and you go to take a certification exam, if you have 5 questions or 20 questions on that exam, you should get 90% of them right. if you're like me and you struggle with math, these are easy points. And there's far too many people who fail the test because they got a 69 out of 100. They missed that passing grade of 70 by 1 point. And a large problem that many of those people have is they're not comfortable with the math. So I go through step by step. This is what I do whenever I'm taking a certification test, as I have in the past, or when I'm at work. I go through step by step. And I do that because typically one of my operators is going to be with me. And I'm always taking an opportunity to train them, to show them something new, to show them something repetitive, something in a repetitive fashion, that this is why we take all these steps. So I write it all out completely. And that helps me ensure that I have all the accurate information, all the knowns. If I have all the knowns, I can calculate the unknown. So we have 0.785 times the diameter, and now we need the depth. The depth here is, it's 18 feet deep. 18 feet. Now let's check our formula. We'll check the units of measure to make sure it makes sense. 0.785, there's no unit of measure there. The diameter in foot. Here's another one. Here's the depth in feet. 1, 2, 3. Checks out. Because it checks out, I should be able to multiply all these together and get the correct answer. 0.75 multiplied by 12. We're going to multiply that by 12 again. The depth, 18 feet. And we're left with 2,034.72 cubic feet. Let's go to my possible answers here. Well, I see F and G are in square feet. I'm going to eliminate those right off the bat. 2034.72. There's a big difference between E and H. The correct answer is H. Question number 10. Oops. Find the volume of a cylinder with a diameter of 27 feet and a height of 18 feet. What is it asking for? It's asking for us to find the volume. The ABC math formula sheet is going to tell us that volume for a cylinder is equal to 0.785 multiplied by the diameter. And in the math formula sheet, it's going to be written like this. Let's rewrite this with the units of measure, which will be volume in cubic feet, because again, we have a diameter of 27 feet, a height of 15 feet. So our units of measure will be in feet. 0.785. We're going to multiply that by the diameter. The diameter is 27 feet. We'll multiply it by the diameter again. 27 feet. And then we're going to use the height. That is 18 feet. Let's check. Let's check to make sure this makes sense. We're looking for cubic feet. 0.785 does not have a unit of measure, but we have the diameter in feet, we have the diameter in feet, we have the height in feet. 1, 2, 3. That gives us cubic feet. So we'll multiply this out and we should get the correct answer. 27 feet times 27 feet times 18 feet. That's going to give us 10,300.72 29.77 cubic feet. Well, let's look at these choices. The first two, A and B, are in square footage. We're going to eliminate those right off the bat. There's a big difference between 382 cubic feet and 10,300 cubic feet. The most correct answer is D. Let's go to question number 12. Question number 12. Calculate the volume of a cylinder with a diameter of 85 feet and a height of 29.75 feet. So we're going to calculate the volume. The math formula sheet says volume is equal to 0.785. This is the factor we use for a cylinder, anything circular. Multiply that by the diameter twice, and then by the height. This is the math, the ABC math formula sheet. This is the formula we're going to use. Let's rewrite that to account for our units of measure, which are in feet. I can see here they're in feet. So volume in cubic feet equals 0.785 multiplied by the diameter, which is with a diameter of 85 feet. I always like to read it again just to make sure that I'm saying 85 feet is not the height. That's happened to me several times. So the diameter is 85 feet. We're going to multiply that by the diameter again. 85 feet. And then we have a height of 29.75 feet. Let's check our formula to ensure it looks correct. We're looking for cubic feet. We have the diameter 85 feet, 85 feet again, 29.75 feet. That's 1, 2, 3. Checks out. Now it's just multiplication. 0.75 times 85 times 85 times 29.75 equals 168,730.84 cubic feet. Let's go to our choices here. I see square feet. We're going to eliminate A and B right off the bat. 168,730. Well, there's a big difference between this number and 2,530. Eliminate that. That leaves D. D is the most correct answer. You can say this. You can see that it's 168,730 rounded up 169,000 cubic feet. All right, question number 13. Before we get going in this, I want to explain a few things. When we look at the ABC math formula sheet, we're looking for volume of a cone. The formula sheet has it written out as volume cone equals 1/3 multiplied by 0.785 times the diameter times the diameter times the height. Now the thing you have to remember about a cone, let's draw this out. When you have a cylinder, a cone is always 1/3 the volume of a cylinder with the same dimensions. What does that mean? Well, you've all seen cones. Some of them cone down to one side or cone down to the middle. So in this case, if the bottom of the cone is here and I draw a line here, I have a cone that angles to one side. And that cone is always going to be 1/3 the volume of a cylinder with the same dimensions. Well, let's say the nose of the cone is right here at the center. Now I have a cone that goes down to the center. And this cone, again, is 1/3 the volume of a cylinder with the same dimensions. 1/3. Now I could take this ABC math formula and I could write it down as in volume. And because this is a 3-dimensional, its volume, it's going to be, and let's check our units of measure. Feet, okay. We're going to go with feet cubed equals 1/3 multiplied by 0.785 multiplied by diameter times the diameter times the height. I shouldn't have written down that cubic, but that's all right. I think you guys understand what I'm trying to do here. Now what I've done, and you'll see it right here, I've included the math formula, is instead of writing it this way, I just divide by 3. You can do it either way, it works. It's the same number. So let's rewrite this formula with our units of measure. Volume in cubic feet equals, and let's start with 0.785 multiplied by the diameter. And the diameter is 13 feet. We're going to multiply it by the diameter again. 13 feet. Then we're going to multiply that by the height. And the height is 7 feet. All right. Now what we're going to do is we're going to divide this by 3. This represents the 1, the division line, and 3, which is represented in the ABC math formula sheet here, 1 divided by 3. Let's count our units of measure, see if it makes sense. I'm looking for cubic feet. I have no unit of measure here, but I have 1, 2, 3, which matches up with what we're trying to determine. Let's multiply this out. 0.785 multiplied by 13 feet in diameter by 13 feet in diameter, the height of 7 feet equals 928.655. Now we're going to divide by 3. Divide by 3 equals 309.55 cubic feet. 309.55. There is no 309.55, but what I have here is a big difference in these values. We're going to pick C. 310 cubic feet. That's the correct answer. Question number 14. A cone has a diameter of 22 feet and a height of 11.25 feet. Excuse me. Calculate the volume of the cone in cubic feet. It wants the volume of the cone in cubic feet. We can do that. Volume of a cone. Volume is equal to 0.785. We're dealing with a cone, which is a cylindrical shape, which is round or a circle, multiplied by the diameter squared, diameter times the height. All right. Let's rewrite our formula with the unit of measures in place. We want volume. This is three-dimensional, so we're looking for cubic feet. 0.785 multiplied by the diameter. The diameter here is, the cone has a diameter of 22 feet. 22 feet. Multiply that again by the diameter. 22 feet. And now we have a height of 11.25. Let's check our units of measure to make sure this makes sense. We're looking for cubic feet. Well, here's 22 feet. There's 22 feet. There's 11.25 feet. That's 1, 2, 3. Well, that checks out. 0.785 multiplied by 22 by 22 by 11.25. That's going to give us 4,274.325 cubic feet. Right away, I can eliminate D. That's in square feet. There's a big difference between these three. 4,274. C is the correct answer. One more problem left. This is the last one. Question number 15. A cylindrical chemical storage tank, 22 feet in diameter and 11.5 that's supposed to be feet in depth, has a coned shaped bottom which is 6 feet in depth. Calculate the volume of the cone in cubic feet. Okay, calculate the volume of the cone in cubic feet. So it's giving us a cylindrical chemical storage tank 22 feet in diameter and 11.5 feet in depth. But it has a cone-shaped bottom, which is 6 feet in depth. Calculate the volume of the cone. Okay, so we want the volume of a cone equals 0.785 multiplied by the diameter twice, diameter times diameter, and we want the depth, which is also the height. For this question, we'll call it depth. So 0.785 times the diameter times the diameter times the depth. Let's rewrite this equation with the units of measure. Again, calculate the volume of the cone. It doesn't matter that you have a cylindrical tank with these measurements. What matters is the cone. So I want volume in cubic feet equals 0.785. We're going to multiply this by the diameter. Now the diameter, the storage tank is 22 feet in diameter. feet. And we're going to multiply it by the diameter again. 22 feet. Then we're going to multiply it by the depth. The depth of the cone, it says the tank itself is 11.5 feet in depth, but the cone shaped bottom is 6 feet in depth. 6 feet. So especially as you go through the higher certifications, you're going to get more information than you need. You have to extract that information to get what you're looking for. This is a cone. So we're going to take this value, or this formula, we're going to divide all that by 3, which right here, I should have written 1/3, because that's what the ABC math formula says. And you know what? I'm human. I'm an instructor. Usually I'm in front of a student body, and there's usually some student, as I lecture, who points out, hey, you missed the 1/3. I'm okay with that. I'm a human being. I make mistakes. Volume in cubic feet equals 0.785 multiplied by the diameter in 22 feet, multiplied by the diameter of 22 feet again, multiplied by the depth, 6 feet. We're going to divide it by 3. We have cubic feet here, so we have 22 feet, 22 feet, 6 feet, 1, 2, 3. That looks like it checks out. It's a cone. We're dividing by 3. 0.785 times 22 times 22 times 6 divided by 3 equals 759.88 cubic feet. All our units of measure and our choices are in cubic feet. 759.88. Well, that's a big difference between the 2,280, the 26,216, the 5,684. 760 cubic feet is the correct answer. Now let me just show you something real quick. Let's do this formula again. 0.785 multiplied by 22 again, by 6. It gives us 2,279.64. If we had not divided by 3, we would have chosen, let's get a different color here, we would have chosen A. So you can see that very often, if you miss a step in a formula, it will be one of the choices. Be very careful not to make that mistake. Again, it goes back to writing everything down, taking the time to write down the formula, to write down the units of measure, and to make your check your calculations, check your formula to make sure it makes sense, and then make your calculation. At this time, I'm going to ask you to please like this video. I'm sure everybody is aware that anybody with a YouTube channel is trying to get likes. We want to get subscribers. As you watch these videos, if you like what I'm doing, please subscribe. Help me out. This is another flow of income for me. I get to help people. I get to put this information out there. It's reliable, consistent information that's going to help you certify and certify up. It's going to help you in your everyday job. Please leave a comment and let's be positive. Let's not knock each other down. Again, you can follow the link to my website. The website will have a free link to the ABC website where you can download your math formula sheets for water or wastewater. You could download both. It also has a link to my PDF downloads. It's very inexpensive, and you get the PDFs to all the math assignments, including the answer keys. Thanks for your time. Hope you enjoyed the video.